taken spelling mistake, spring it is. During its rebound, I think straight away go to the set of diagrams. So this is the here is a block. It is released from rest, and what is the state of this? It is at rest. Then when it arrives here, what is the state of this block? Still it will be at rest only. This will come and get stuck to it. What is the state of this block? It will have some velocity v1 because it will fall through ith h, no, in the gravity. Then what is the state of spring? It is relaxed here. So you have to make observation of all this. Then what is the state of spring? Spring is relaxed. Spring is massless, no? Then now what this block will do? It gets stuck to the spring. Now here, and because of velocity and weight, it will start moving down. It will start descending down. Then it will come and compress the spring. Very good problem for students to learn. Huh? Still this block will be at rest. This will be at instantaneous rest. IR, I'll write it. Everyone should understand what do you mean by IR. Instantaneous rest it is. So spring got compressed. Let's take this as some natural, some position. What are the forces that will be acting? Here spring force kx1, the weight mg, normal contact n1, m1g, and the spring force at this end. Because compressed, no, spring is compressed means it should act. No, well, the block will lose contact. Previous problem only, instead of giving force, I brought the velocity. It is dropped here. Now when it lose contact, when spring is elongated, so again it will come back to this position, the block. Say that v1, and finally it will elongate. So when it is to this position, now what is the state of spring? Spring got elongated. Spring force, it will lose contact. This will be at instantaneous rest, and where this will be at rest. So how the spring force? Spring force will be acting here downward. The weight also will be acting downward. Now, what was the question? At what height h it should be released, no? So that it will lose contact here. For the lower block to lose contact, what is the requirement? Kx2 should be greater than or equal to mg. Minimum is telling. Why that minimum word will analyze here. So kx2 okay, this one. Then it is released, dropped from ith. So shall we apply now? The decrease in gravitational potential G will get converted into increase in kinetic energy of the block. Here v1 I'm writing it. So therefore this v1, right, 2gh. Now what is this kx1? How this spring gets compressed? Spring force I'll show by red color. So shall we apply conservation of mechanical energy between these 2 points? So give the number. Okay. 1, 2, 3, 4. So let's apply conservation of mechanical energy. E1 equal to E2. E1 is equal to E2. So what is E1? E1 will be mv1 square by 2 kinetic energy plus gravitational potential energy mgx1, kinetic energy 0, sorry, elastic potential 0. I'll write all the things. What is the total mechanical energy? Kinetic energy, gravitational potential energy, elastic potential energy of spring should be equal to kinetic energy of block, gravitational potential energy plus elastic potential energy. G means gravity, S means spring energy. So kinetic energy of block mv1 square by 2, gravitational potential energy mgx1. Spring is at natural length at position 1. Kinetic energy of block, it will come to instantaneous rest. IR I wrote it, no? 0. Gravitational potential 0 because I am going to take this as h equal to 0. So at what height the block m is there in the initial position 1, mgx1. When the block is here, what is the gravitational potential? Will be 0. Elastic potential energy in the spring. This much is what we have. We have to get that h. So h depends on what all parameters. So final equation will be v1 square, we can write 2gh, so this will become mg plus mgx1 equal to kx1 square by 2. I have till here. Now let's do one thing. I'll apply conservation of mechanical energy between the position 2 and 3. Carefully check it. Kinetic energy of the block, gravitational potential energy, elastic potential energy of spring, kinetic energy of block, gravitational potential energy, elastic potential energy of spring. Kinetic energy of block 0 because it will move from rest to rest. IR I am writing, nearby IR I am writing instantaneous rest it is. Gravitational potential energy, I'll take this is 0. Elastic potential energy of spring kx1 square by 2 plus kinetic energy of block there 0. Rise in gravitational potential energy mg x1 plus x2. Elastic potential energy of spring kx2 square by 2.
So it should be 4, no, sir?
What 4?
If
E4. Okay, this is 2 and 4, no? Yeah, okay, fine, yeah, thank you. Between 2 and 4 we applied it. Conservation of mechanical energy. Then solving this, kx1 square by 2 I think one x1 x2 will cancel out, so k kx2 I'll write it as mg. From where? From this equation. Let me write all the, I'll call equation 1, 2, 3. Put 1 in 3. So kx1 minus mg equal to mg. So what is kx1 is equal to mg? This is 4. Put 4 in 2, then we'll get the required answer. x1 I'll write mg by k. x1
kx1 should be 3 mg, sir.
3 mg, yeah?
yes,
Okay, this one. x1 will be 3 mg by k. So this will be m gh 3 m square g square by k 9 m square g square by 2k. Anybody value of h? Mg will get cancelled. 3 mg by 2k will come. Say the same previous problem, little bit different way. The force we have brought now, here we are going to release the block certain height so that the block after striking the spring will get attached to the spring. Then it will go and compress the spring. Then after compression, the block will not lose contact. Again the block will rise up. When it gets elongated, then lose contact. What is minimum h is telling? So when the h is minimum, the block will be at instant rest. This block will be at instant rest. If you release at a height more than this, when this is losing contact, this will have some velocity. Now sir, how do I should think? This is one primary thing that one. Maximum students, what happen? They're bothered about writing equation. I am suggesting you that leave these equations aside. What actually happens here? This diagram is very important. Looking at this diagram, anybody can write equation. Conservation of mechanical energy only. So it should lose contact. Here, what is this? This will lose contact, no? For it to lose contact, the spring force should be greater than mg. So you are going to write this equation. You drop it from certain height. So what is v1? Root of 2gh. Then conservation of mechanical energy. Only spring force and weight are doing work. Then again conservation of mechanical energy between these two. Unknowns are more. You'll get an idea what to do. What is the problem with the students is like they want to write this equation without diagram. I don't know what is the science here. What science how you are learning. So everyone, my sincere request that you draw the diagram. You understand what actually is going on. Once you understand what is actually going on, rest all very easier. I'm able to draw the diagrams. I'm able to write equation because I am looking at diagram and writing equation. You see that. So it'll be very challenging for students, spring block system especially. Drawing the diagrams. It's a like almost from starting of physics I was insisting you to draw the diagram. The only reason is like it'll be very easy for you to write equation. You'll understand the question itself. Once you understand, writing equations are very easy. Let's see how many of you really draw diagram. Only 5% of students they have a patience to draw diagram. Remaining all by seeing question they want to write equation, solve it, and within 1 hour some 100 problems they want to do. I don't know. Will you get any gold medal? God only knows. 1 hour you solve 5 problems, but you understand them first. Sir, what makes the spring to get compressed? I think this is a natural thing which is happening. Everyone must know that when the block will go and compress the spring. After undergoing compression, what is the state of block? Block, what happen will undergo what type of motion? Will undergo retarding motion, no? Because mg will act downward. Kx1 will act upward. Then what is the state of block? For what type of motion? Will start undergoing retardation and finally comes to rest here. Sir, what is the type of motion? Can you tell? As mg, first it will undergo accelerated motion. Decreasing acceleration, increasing speed, somewhere maximum speed. Then because of maximum speed, further it will move down. Then the spring will undergo further compression. Then spring force will become greater than mg. Then it will start undergoing further compression. Then undergo retardation. Then comes to instant rest. What is the motion of the block from 1 to 2? First acceleration, then retardation. Oh, already morning I had done vertical spring block. That is what needed here. Sir, every problem we have to draw the diagram as the sequences. What actually happens? Compression, elongation, state of the blocks, rest, or in motion. All this is needed for us.